Today we're taking a look at what happens when we go beyond CPCTC. We have two definitions that are going to lead us to all the proofs that we're doing today, and they're altitude and median. And in a lot of cases these segments are the same, but we have to know the distinction between the two. A median is a segment drawn from the vertex of a triangle to the midpoint of the opposite side. So as in our diagram here, we can tell that segment AC is the median if we know that that's true. That means that BC is going to be congruent to DC. And again, you'll be told that in the given information, or you're going to have to try and conclude that AC is a median. We're not going to assume that. We'll have the information to figure that out. But if you notice here, it's basically a bisector. It's going to take that segment BD and break it into two equal parts. Median, if you think back to driver's ed, it's the middle of the road. So there's that divider in the middle of the road. It's going to break it into two equal parts, and that's where you're going to find a median. An altitude is a segment drawn from a vertex of a triangle. The vertex, again, is just the corner of the triangle, to the perpendicular to the opposite side. So in our diagram here, if AC is an altitude, that means that it's perpendicular to BD. Or in other words, it's going to form right angles. So altitude, perpendicular, they're very similar ideas. Let's look at how this works in a proof. We know that RE is an altitude to AB, so there's that keyword again, altitude. We have circle R, so I know something about radii. And I'm trying to prove that triangle ARE is congruent to triangle BRE. So the proof itself is not going to be very lengthy because we're not going past proving the triangle is congruent. But we have that new word there, altitude. And an altitude for us means that we have right angles. So I'm going to start by marking this off, and anything that I have to actually include in my proof I'm going to put in red. So if I know that RE is an altitude, then that means that it is going to intersect segment AB and form right angles. And eventually I know that these right angles are congruent. The second given here is that we have a circle. And circle tells me, if I have that in my given, that the radii are going to be the same. And I've got two choices. I definitely want to say that RA and RB are congruent, and if I want, I can lump together RE because it's also a radius. If you want to, you can separate that out as a separate segment, RE, and call it reflexive property. But I'm going to lump them together. So looking at my information that I've got now, I have a side, an angle, and then another side. And a side, an angle, and another side. So it seems to me like we're going to use the method SAS to prove that these triangles are congruent. So let's set up our chart. So I started off using the altitude, and I said if we have an altitude, then that means that angle ERA and angle ERB, oops, there we go, are right angles. How did I know that? Well, it was from the given information that I had an altitude. So I'm going to say an altitude forms right angles. We've been talking about this since chapter 1, but we know that if we have two right angles, that they're going to be congruent. So I'm going to say angle ERA is congruent to angle ERB, and that's because all right angles are congruent. So I've got a pair of angles there mentioned. Now I've got to figure out the sides. And we knew the sides because of the fact that we had a circle. So I'm going to say that AR, or we'll call it RA, we'll start at the center, is congruent to RB, which is congruent to RE. And that's because all radii, oh, whoa, what happened there? Connection error. There we go. All radii of a circle are congruent. And now from there, because I have the pair of angles and then those two pairs of sides, I'm going to say that the triangles ARE and BRE, they have to be congruent. And it's because of SAS. Alright, next one. Sorry about that. And this one we're trying to show that we have a median. So we're trying to show in the end that we do have those segments that have been bisected. So I'm going to start off with AB congruent to CB. That's my given information. I'm told that BD bisects angle ABC. So I'm going to take this angle right here and I'm going to break it apart in those two equal pieces. And in order to show that it's a median, I'm going to have to show that AD is congruent to CD. But in order to do that, I'm going to have to show that the triangles are congruent. Now, we're not going to assume from the picture that they're not. We're just going to go with the diagram that we've got. I don't know that BD is also congruent to itself because of the reflexive property. So again, if I set up my diagram, and we're going to try it this way. The green stuff is good to go at this given information. I don't need to worry so much about that. Now I need to look at this. I'm going to say that angle ABD is congruent to angle CBD, and that's because an angle bisector cuts an angle into two congruent angles. And then from there, BD is congruent to itself. That's the easy step. Reflexive property. And now we have enough information to say that we have a side angle side relationship again. So then the triangles are congruent. SAS. Now from there, I'm trying to show that I've got a median. To show I've got a median, I have to show that a segment has been cut in half. And the segment that's got to be cut in half is AC, because that's BD is the median to that segment. So if I can show that AD is congruent to CD, then I can show I have a median. Now, anytime you go one step past the triangle proof, your next step has got to be CPCTC. It's always in that order. And then we have our median. So I'm going to just kind of copy that down because you guys know what that proof statement is going to be. And that's because a median cuts a segment in half, breaks it into two equal parts. Now look at that, we did 5 steps past the given. That's a pretty intense proof, but one that we're capable of doing. Alright, last thing we're going to talk about today is auxiliary lines. We'll go through this pretty briefly. In some diagrams, not everything's going to be there. It looks like just about everything's there, but there's something missing. In some cases, we're going to have to draw in segments to make two congruent triangles in order to make this proof work. In a proof, if you draw something in, you need to state that you drew it in. And you'll see that in the next example, we're going to have to draw something in. And the reason that we're going to put on the reason side is 2 points determine a line. So in example 3, it looks like we've got everything we need, but we don't. We have enough information to show that JK and JM are congruent. I know that L is the midpoint of KM, which is going to tell me that these two segments are congruent. We haven't learned this yet, but there's a theorem that says something to the effect of if you have two pairs of sides congruent in the same triangle, the angles across from them are congruent. But we don't know that one yet. So we've got to think of a different way to do this. The only way we know how to prove pieces of triangles is to show that we have triangles congruent. But I have one triangle, not two. So I need to get another triangle in order to make this work. So the next thing I'm going to do is I'm going to try and get a line, and I'm going to see how well this works out. I'm going to draw a line from J to L. Now in my proof I'm going to write draw JL as one of my steps, and my reason will be 2 points determine a line. And then from there I'm going to say that JL is congruent to itself by the reflexive property. I can prove the triangle is congruent by side, side, side then, and then from there angle K has got to be congruent to angle M. And that's how you're going to work auxiliary lines in a proof. If you don't have two triangles, get them. Draw in the segments that you need to, and your reason will be 2 points determine a line.